Good morning, I'm Steve, welcome to Malaysia. We're here at the Nottingham University Engineering Research Building and we're going to have a look at the sequestrate test reactor. So this is a general introduction to the test rig. The purpose of this rig is to react a variety of readily available minerals with water and carbon dioxide under a wide range of different process conditions. And the purpose of doing that is to make a strong bicarbonate solution which can subsequently be diluted and then discharged into the sea, safely discharged into the sea. And this is Aparav, who's been running the test rig for us. This is the front of the rig with the control panel supplied by Chemtrol. This is a standard piece of water engineering equipment, and it transmits the data up to the cloud and it can be downloaded into Excel files. We're monitoring the turbidity, the pH, conductivity, temperature and flow, so that's a nice standard piece of industrial equipment. The panel here on the right, it supplies the power for the pump, which we'll see in a moment, and the rest of the instruments. We have a three-way valve here which allows us to divert water into one of the dilution systems. So on this side of the rig we have a inline cooler, a sight glass which is very useful for seeing what's actually happening in the system. We have a mag drive sealed variable speed pump and a nice little flow meter, so the flow meter has a local reading here. And in the back we have the expansion pot. So this is the back of the rig. We have the expansion pot again, and we have the main system drain which goes down to the floor drains, and the drain which lets out the water from the CO2 addition system and also from the solid reactant addition system. So we have a pressure recorder, a pressure relief system, a conductivity meter, a turbidity meter, and a industrial pH meter. So now we're looking at the CO2 addition system. So we have a regular CO2 bottle with its main isolator, a nice pressure regulation system, and a HP hose. The HP hose goes into the CO2 addition bottle. So this can take several bar pressure, 10 bar pressure or more, and is 2 litres of volume, so we know exactly how much CO2 is being added to the system. So a charge of CO2 is put into the bottle and is added to the circulating loop at the bottom here. Water is added into the system through this hose connection and this water line. So this is the point where we put solid materials in. So calcium carbonate, magnesium hydroxide are added into this part of the system. There's a mixing pot at the bottom, and water can be diverted through this to add the solid into the circulating system. When the solid is mixed in, you can see it appearing in the sight glass here. So this is a general description of how the system works. We add water into the loop, and the water is circulated around this horizontal section by the pump. CO2 is added into the loop at the desired quantity and pressure through the addition system here, and the solids are then added at the back. So it's possible to have 2 litres of water in the system, followed by several grams of CO2, followed by several grams of the solid material that we want to put in. These 3 large side reactors are used for dilution. So in one arrangement we can set up a charge of 2 litres of liquor circulating within the test rig and then dilute it through one of these vessels against 15 litres of water to see what the step change is with dilution. In this current arrangement of the 3 additional vessels, we have water coming in through the hose here into the first contactor with CO2 coming in at the top. The CO2 and water contact together, pass through the bottom of the first vessel, up through limestone pebbles in the second vessel, around the big pipe, and then up again through more limestone small size material in this vessel, and then that out. And once it reaches the rig, it passes over the existing sensors and gives us the standard set of data. So this 3 reactors in series followed by the sensors allows us to do a continuous flow test, an open loop test, as opposed to the closed loop test that we were doing previously on the rig. These are some of the chemicals that we used. Obviously calcium carbonate, plenty of buffer solution, sodium chloride for seawater simulation, plenty of magnesium hydroxide and magnesium carbonate, and some of the other readily available minerals. We've also been able to use some calcium carbonate sand that we acquired from the lime factory in northern Malaysia.